All right, in this video, we're going to practice plotting parametric curves point by point, just like we did many years ago when we learned how to plot functions themselves. So I want to emphasize right off the bat that parametric curves, these things live on the XY plane. So that's where we're going to plot these on the XY plane itself, in comparison to what we previously did for extracting the coordinate functions x of t and y of t from the curve itself, where we had x versus t and y versus t. Those were just representatives of those individual components of the parametric curve, x of t, y of t. Where we actually want to plot the parametric curve itself is on the xy plane. So the parametric curve that we'll talk about today, or in this video, will be the parametric curve x of t is equal to 2 cosine t, and y of t is sine of t plus 1. And let's go ahead and try to plot this parametric curves for values of t between 0 and 2 pi. So how do we go about doing this? Well, if we're going to plot point by point, what you might remember when we learned how to plot functions previously was we can start making big old tables of a bunch of values that we want to plot, x and y, as those individual components. So this is our goal. Find those coordinate pairs of x and y that will plot together. But remember, for parametric curves, x and y depend on this parameter t. So let's choose a couple t values and then figure out what the corresponding x and y values are. And since we want to plot between 0 and 2 pi for this particular example, we want to break that interval 0 to 2 pi up into somewhat many points, maybe at least, on the order of somewhere around 10-ish points or so. So we can start off with t values, and let's break this up from 0 to 2 pi and maybe steps of pi over 4. We can always go back and add more points if we think it's necessary. So we can go 0, let's say pi over 4, pi over 2, 3 pi over 4, pi, so we're halfway there, 5 pi over 4, 3 pi over 2, 7 pi over 4, and then finally 2 pi. So what we want to do is take those values of t, plug them into the equations for x and y, and figure out the x and y values that we'll actually plot. So for example, we take that t value for t equals 0, we plug it into our x equation, 2 cosine of 0. What that gives us is a value of 2, since cosine of 0 is 1. If we do the same thing for the y equation now, y is sine of, this time 0 plus 1. In this case, sine of 0 is 0, so y is just equal to 1. So the first point that we would plot would be the point x is 2 and y is 1. So we can do this one of two ways. We could plot this point and then come back, find the other points. Let's just figure out all the points and then plot them all. So the next values, we have cosine of pi over 4. All right, cosine of pi over 4 is, don't know why I paused, no one else is here. Well, this is 2 times the square root of 2 over 2. Or what this is really boils down to is the square root of 2, right? All right, let's see what sine of, or the y equation is. So we have sine of pi over 4, and then plus 1. So sine of pi over 4 is actually the same thing as cosine of pi over 4. It's square root of 2 over 2. So what we get in this case is square root of 2 over 2 plus 1. All right, so what point will we end up plotting here? For the x, that is the square root of 2. For y, this looks a little more complicated. We could write this as 1 plus, well, 1 over the square root of 2. All right, let's plug in some more points. Pi over 2. We'll get 2 times the cosine of pi over 2. In this case, or in general, cosine of pi over 2, 0. So this is a big old 0. Sine of pi over 2 is not 0 though. Sine of pi over 2 is actually equal to 1. So We have sine of pi over 2, 1 plus 1 gives us a 2. So the next value we plot, 0, comma 2. And we can keep moving along in all of these cases, moving on to cosine or pi or 3 pi over 4, excuse me. Cosine of 3 pi over 4 is a negative square root of 2 over 2 times 2. Well, gives us basically the same thing as the cosine of pi over 4, just with a negative attached to it. So this is actually equal to minus square root of 2. And what's going to happen for sine? Well, sine of 3 pi over 4 plus 1. Sine of 3 pi over 4 has the same value of sine of pi over 4. So it's actually going to give us the same exact value from earlier. It's going to give us the square root of 2 over 2, or the 1 over square root of 2 plus 1. So the next point that we plot is a minus square root of 2, and then the same y value as the pi over 4 case, 1 plus 1 over square root of 2. All right, let's keep going with pi. So cosine, or 2 times cosine of pi. Cosine of pi is a -1, which makes 2 times -1 a -2. All right, evaluating the y equation at pi, we get sine of pi plus 1. Well, sine of pi is 0 plus 1. That thing's equal to 1. So our next point that we plot will be a -2, comma 1. And actually, we could keep going along with all of these points in this manner. So if you want to keep practicing some of these trig values, I think that's very worthy of notable of doing. If we plug in 5 pi over 4 into our x equation, what we'll end up getting is the same value as the 3 pi over 4 case. We'll get a negative square root of 2. If we plug in the 5 pi over 4 into our y equation, we'll actually get something similar to other cases we've done. Actually, let's just go through that. So sine of 5 pi over 4 plus 1. Sine of 5 pi over 4 is a negative 1 over the square root of 2. So what this equals is actually 1 minus 1 over the square root of 2. So the point we plot here is that negative square root of 2, and then 1 minus 1 over the square root of 2. All right, looking at the 3 pi over 2 case, well, cosine of 3 pi over 2, same as cosine of pi over 2, that thing is 0, so x is equal to 0. Sine of 3 pi over 2 is -1. So we get a -1 plus 1, sine, or that y equation is equal to 0. So this point is 0, 0. 7 pi over 4, if we evaluate 2 times cosine of 7 pi over 4, that'll actually give us the same cosine value as pi over 4 before. So this value is actually equal to the square root of 2. If we plug 7 pi over 4 into our y equation, we actually get a similar value to the case when we had 5 pi over 4. So sine of 7 pi over 4 is a -1 over the square root of 2, or negative 2 over square, or it's negative square root of 2 over 2. So we end up getting is a 1 minus 1 over the square root of 2. So this point that we plot is a square root of 2, 1 minus 1 over the square root of 2. And finally, coming back to 2 pi. Well, cosine of 2 pi, 0. Or sorry, cosine of 2 pi is a 1. Excuse me. Cosine of 2 pi is a 1. So 2 times the cosine of 2 pi, that thing gives us a 2. And then finally, when we plug that value of 2 pi into the y equation, we get sine of 2 pi, which is 0. So we get 0 plus 1, which gives us a 1. So this point is actually the same point that we started with, 2 comma 1, 2 comma 1. So let's go ahead and try to plot these points down below. All right, so we have our XY plane. And the way I'm going to look for this is I'm just going to scan and see sort of what's the largest X value we need. Looks like the largest X value we see is a 2. The smallest X value we have is a -2. So it looks like maybe we can keep our X's between, 2's kind of value. In terms of Y, we see similar looking things. The largest value is a 1 plus 1 over the square root of 2. And then the smallest value appears to be actually 0. So our Y values really are kind of going above the x-axis in this case. So let's start plotting some of these points. So plotting the first point, 2, 1, we again march in the x direction 2, go up 1. So our first point we're plotting is there. All right, what's the next point? We have the square root of 2, and then 1 plus 1 over the square root of 2. Well, square root of 2 is approximately 1.4 and change. So 1 over 1 plus the square root of 2, that's a 1 over 1 plus something. That number is still somewhere between 1 and 2. So what this value really looks like is somewhere slightly greater than 1 and somewhere smaller than 2. So let's actually mark these points. So this is t equals 0, and this second point here is t is pi over 4. All right, what's the next point? Well, we go 0, 2, when t is equal to pi over 2. So x is 0, y is 2, and this is our t value. T is pi over 2. Let's keep going now. All right, the next point we have is x is a minus square root of 2. So that's minus 1.4-ish. And 1 plus 1 over the square root of 2. Well, that's some number between 1 and 2. So it looks like we're somewhere between about negative 1.4, somewhere between, 1 and 2. So we're basically at that same y value as earlier. So let's go ahead and plot that. Again, we're kind of just sketching this out. All right, and that is t is equal to 3 pi over 2, or 3 pi over 4, excuse me. So the next value is negative 2, 1. So we go in the x direction, minus 2, and we go up 1. So that is t equals pi. And we could keep doing this. So we zoom in here a bit. We just finished the t minus 2 case, or minus 2, 1 case. Our next case is a minus 2, 1 minus 1 over the square root of 2. That second y value, well, that y value will be somewhere between 0, 1. We're again at negative square root of 2, so we're 1.4-ish. So we're somewhere down here. So this value is t is equal to 5 pi over 4. All right, what's the next t value? Well, actually, we're at 0, 0. So the next t value we think about, x equals 0, y equals 0. That's an easy one for us. We're basically right at the origin, and this is t is equal to 3 pi over 2. Moseying on along then, our next x value is square root of 2, so 1.4-ish. 1 minus 1 over the square root of 2. Well, that's somewhere between 0, 1. So that's t is equal to 7 pi over 4. And then finally, the last point that we think about, x is equal to 2, y is equal to 1. We are back where we started. So this point, t equals 0, is also the same point that we have for t equals 2 pi. So that to say, the same or different t values can bring us back to same point along the curve. And the last thing we could do here, well, this curve has a direction to it because t is increasing. So we're going to go around this curve in the direction of increasing t. And this curve looks something like this. If we drew this a lot better, we would actually see this actually traces out an ellipse for us. Not that you need to recognize that from this particular plot or these equations right now, but we actually get an ellipse from these two parametric equations we started with. So this is how we can plot points using or plotting parametric curves by going point by point, making a big table and then plotting all of those points individually, and then making sure that we construct that curve and give a direction to that curve indicative of the increasing values of that parameter t.